To start problem 9, I'm going to work with the left-hand side and go ahead and rewrite everything in terms of sine and cosine. And now that I've got that written in fraction form, I see that there's a couple things there that are going to cancel out on the numerator and denominator. So since both those fractions cancel out, that just leaves us with a 1 right there, and then we still have the minus sine squared. Now, based on a manipulation of the Pythagorean identity, 1 minus sine squared turns into cosine squared, which is what we have on the right-hand side. And so we are finished with that one. To start with number 10, I'm going to go ahead and work with the left-hand side again, since it's not written in terms of sine and cosine, and do that as my first step. Now we've got a bunch of fractions in there, and we want to go ahead and get common denominators so that we can cancel those denominators out. So that'll be my next step with the 1 in the denominator. Now all of our fractions have a denominator of sine theta, and so we can cross out those denominators. And then this is what we're left with. And that's as far as we can take the left-hand side. So now I'm going to go ahead and switch over to the right-hand side. And since the numerator is in terms of sine, and it's possible to get the denominator in terms of sine as well by using that manipulation of the Pythagorean identity, I'm going to go ahead and do that first. And that makes sense because that has the factoring pattern of the difference of two squares. And one of those factors in the denominator is going to cancel with our entire numerator. So that leaves us with 1 over 1 plus sine theta, which is the same thing as we got the left-hand side to look like. In number 11, I can see that we've got an addition formula embedded in the left-hand side, and so I'm going to use a trick that we used earlier in the practice test and isolate the term that has a special formula to go along with it. And so I'm going to isolate that term by multiplying both sides by sine x cosine y. And you have to make sure and distribute that to both terms on the right-hand side. And now, by the way it looks, the right-hand side is more complicated, so I'm going to work with that side and rewrite everything in terms of sine and cosine. I'll go ahead and make everything look like a fraction as well to see if anything will cancel out, and in this case it does. So once we cancel out common factors in the numerator and denominator, that leaves us with cosine x cosine y minus sine y sine x. And that actually proves our identity because that formula is the addition formula for cosine. On number 12, I'm sure that there's more than one way that we could do this one, but right off the bat I recognize that the denominator on the left-hand side and the numerator in the right-hand side both would make up factors of that common factoring pattern of difference of two squares. So the first thing I'm going to do with this is use cross multiplication. I mean, that'll also get rid of our fractions too, maybe make it a little bit easier to work with. And so now I'm going to focus on the left-hand side, since that's not all written in terms of sine and cosine right now, and that'll be my next step. I've got a sine in the denominator, and then sine to the third in the numerator. So one of those will cancel out, leaving us with just sine squared. Sine squared can be rewritten as 1 minus cosine squared. And again, that is the difference of two squares, so we can go ahead and factor that in order to make it look like the right-hand side.